students also. To join the session, shall I continue? Yeah, ask the other people to join the session. Due to some technical problem, I lost my Wi-Fi connection and unable to open Zoom app also. Ask your friends to join the session. Due to some technical problem, I am unable to open Zoom till now. Now it is okay. Yeah, all of you join the session. Yeah, shall we start? Okay. Incomplete data. When we talk about incomplete data or missing data, the data is not available. Missing data may be due to equipment malfunction, inconsistent with other recorded data, data not entered due to misunderstanding. Certain data may not be considered important at the time of entry, right? Missing data may need to be inferred, right? And how to handle missing data? Okay, if the data is missing, how you can fill that particular data, right? Ignore one is that ignore the tuple, ignore that value, fill in the missing value manually. Manually, we can fill the value or fill in the value automatically with a global constant, generalized constant, unknown, are not available, all these things, right? Noisy data. Noisy data is nothing but random error or variance in a measured variable. Incorrect attribute values may be due to faulty data collection, data entry problems, data transmission problems, technology limitations, right? And other data problems which require data cleaning, that is duplicate records. Okay, there is a possibility of duplicate records, incomplete data, inconsistent data, right? How to handle noisy data? Okay, these are the techniques. We call it as binning, regression, clustering, combined computer and human inspection. Binning is nothing but first sort the data and partition into equal frequency bins. Then one can smooth by bin mean value. Okay, we can consider the mean value or median value or the boundaries also, right? We'll see with examples. Data cleaning as a process. Data discrepancy detection. Use metadata. Check field overloading. Check unique rules and use commercial tools also. Yeah. Data migration and integration. Next one, integration, data integration. What do you mean by data integration? Combines data from multiple sources into a coherent final storage. Okay. For example, schema integration. Schema integration means we are collecting data from different resources and each resource has its own schema, different schema and unique schema. Okay, all those schemas must be integrated at one place finally, right? That's the problem. Entity identification problem. Okay, entity identification problem means, okay, in one data set, some entity name is one. In another data set, the same for same values, the attribute value may be different, but their purpose is same, right? Identify real world entities from multiple data sources. For example, Bill Clinton or William Clinton, detecting and resolving data value conflicts. Okay, conflicts between data values, right? That means for the same real world entity, attribute values from different sources are different, right? Handling redundancy in data integration. Redundant data often when integration of multiple data sets. One is object identification and derivable data, right? Okay, these are the general one. Correlation analysis. This is also very important in data mining process by using equation that comes under nominal data chi-square test. We call it as chi-square test. These are the some of the example calculations, right? Correlation analysis equation is there. These are not relevant for as per our syllabus. Just we need only the data cleaning process, basic thing. We will leave it covariance, data pre-processing, and data reduction. So what's the idea of data reduction? Okay, reducing the data, obtain a reduced representation of the data set that is much smaller in volume, but it produces the same value, same analytical results. Okay. Why data reduction? A database or data warehouse may store terabytes of data. Complex data analysis may take a very long time to run on the complete data set. If the data set may contain, for example, for some attributes, if the data value is very big, okay, you cannot handle that very big, large amount of data, okay. That means we need to reduce it to some level so that we can easily calculate. Again, after understanding, we can change it to some other value, right? Dimensionality reduction, numerosity reduction. Okay, all these are the next forthcoming techniques in coming chapters. Data reduction, that is curse of dimensionality reduction, and reduction techniques. These are not available, not necessary as per our syllabus in detail. Next one, we have principal component analysis is there. Principal component attribute subset selection. This is also very important. Attribute subset selection. So what do you mean by attribute subset selection? Okay, when we talk about a data set, okay, large amounts of data sets are there. Large amount of data set contains n number of attributes. For example, 20 attributes, 30 attributes, or 40 attributes, or 50 attributes. Attributes and their values and records, transactions. But when it comes to a particular problem, okay, to find a solution for a particular problem, or when we talk about the particular problem, we does not require all the attributes. We require only some of the attributes of many. For example, out totally 30 attributes are there. Out of 30 attributes, just we will consider only 10 attributes or 15 attributes for a particular problem, for a particular situation, for a particular job or task. Okay. This is the idea of attribute subset selection. Another way to reduce the dimensionality of data. Because of redundant attributes, large amounts of attributes are there, right? Duplicate, it may be duplicate. For example, purchase price of a product and the amount of sales tax paid, irrelevant attributes. Okay, most of the time, in a data set, 30-40 attributes are there. Out of 30-40 attributes, around 10 to 20 attributes will be irrelevant. Okay, unnecessary information. But as a record, they used to maintain all the attributes. Heuristic certain attribute selection. Which attribute is to be selected like that? Feature generation, data reduction, that is numerosity. Okay. And linear regression. Next, we will see about the data warehouse, histogram representation, clustering. So what is this clustering? Partition data set into clusters. In the beginning, first starting class, we have discussed about the clustering. Clustering is nothing but grouping the related things. Okay, what are the characteristics of some elements or components are there? All those are related together. We need to group all those things. Partition data into clusters based on similarity and store cluster representation. For example, centroid or central point, we can say. Centroid or diameter only. It can be very effective if data is clustered, but not if data is paired. We can have hierarchical clustering and be stored in multi-dimensional index tree structures, right? Sampling. Okay, we all know that one. As per the mathematics, sampling means, okay, when we have large amounts of data is there, okay, thousands of records are there. Out of thousands of records, okay, we'll consider only the samples. We'll take some samples out of 100 records. Okay, we'll randomly select some 10 records or 15 records or 20 records for some calculation, some measurement, right? Sampling is nothing but obtaining a small sample S to represent the whole data set N. Allow a mining algorithm to run in complexity that is potentially sublinear to the size of the data. Yeah. And types of sampling, when we see the types of sampling, simple random sampling is there, sampling without replacement, sampling with replacement, stratified sampling. Okay, all these are not needed as of now. These are the examples. For example, sampling, cluster or stratified sampling is there. This is raw data and this is the cluster data, right? Same color, just see the colors. The blue circles are there, green circles are there, white circles are there. Okay, grouping the related elements or components. Data cube. Okay, data cube aggregation, which is the lowest level of a data cube, or we used to say that base cuboid. The aggregated data for an individual entity of interest. For example, a customer in a phone calling data warehouse. Okay, multiple levels of aggregation in data cubes. Further, which reduce the size of the data to deal with, right? Data reduction, compression. This is also very important. Compression, string compression, audio video compression, time sequence is not audio, dimensionality. Okay, when we talk about data compression, and if the data type is image or audio or video, live video is there, live streaming is there, in those cases, to perform the mining process, we need to perform the compression, data compression, right? String compression. There are extensive theories and well-tuned algorithms. Typically, all these compressions comes under lossless, but only limited manipulation is possible without expansion. And when it comes to audio video compression, typically lossy compression. Okay, when it comes to audio and video data is there. Okay, while compressing, we may lose the some amount of data while compressing. With the progressive refinement, sometimes some fragments of signal can be reconstructed without reconstructing the whole, right? Okay, this is data when you see the diagram of data compression, original data is compressed data. And if it is a lossy data, some amount of lossy data is there, original data, it is approximated nearer to the original data. And when we talk about lossless data means original data. If there is a loss means, okay, original data which is approximated nearer to the original data. And data transformation and discretization. So what is the data transformation? Transforming from one value to another value, one form to another form, so that we can easily understand. Okay, data transformation is nothing but a function that maps the entire set of values of a given attribute to a new set of replacement values. That is, each old value can be identified with new values. So what type of methods we have under this data transformation? That is smoothing, remove noise from data, attribute feature construction, aggregation. Aggregation means summarization, summary or data cube construction, or we can go with normalization, scale to fall within a smaller. If the values are very big or larger, okay, we can convert it into smaller values, range of value, normalized. In mathematics, we used to say that normalization process, okay, within a smaller. Okay, for example, when we talk about the maps, okay, map is there, thousands of kilometers of range is there, all those thousands of kilometers are converted into centimeters, right? Normalization. Min max normalization, okay, we have some techniques, z score normalization, normalization by detection. Okay, these are the calculations, some examples. Min max, what do you mean by min max, z score, and normalization by decimal scaling. So next one is a discretization. So there are three types of attributes, that is nominal, ordinal, and numeric. So what do you mean by nominal? Values from an unordered set. That is, for example, color is there. When we talk about color, our profession is there. Okay, we cannot sit in a particular order. Okay, ordinal values from an ordered set. For example, military or academic rank. When it comes to numeric values are there, we know that real numbers, integers, all those things. And data discretization, simple discretization, binning. Okay, just to see one example. Sorted data is there. When we talk about binning method for data smoothing, sorted data for price, okay, in dollars, okay. These are the values, price values are there, which are in sorted 489. Okay, partition into equal frequency. Okay, bin 1, we can say that 4, 8, 9, 15 equal. Each bin contains 4 values. First four in bin 1, first 4 values, next 4 values in bin 2, and the remaining 4 values in bin 3. And smoothing by bin means okay, whatever the first 4 values are there, will we try to find the average of the first 4, that is 9, and the average of the second bin, that is 23, and that means finally we can have 23, 23, 23, 23, and bin 3 is there. Okay, we used to find the average of 26, 28, 29, 34. For that we'll get the 29, and we'll keep all the 29 in bin 3, right? And smoothing by bin boundaries. Boundary means we can consider the first value which is nearer to the minimum value or the maximum value. 4, 4. 4 is nearer to 4, 8 is nearer to 4, like that, 9 is near 4, and 15 is near to 15, right? The minimum, okay, which is nearer, whether it is nearer to the minimum value or whether it is nearer to the maximum value, right? And these are the discretization classification. And next we'll start another one. Wait a moment. I'll open another slide that is regarding data warehouse. Yeah. Yeah. We'll see what is data warehousing and online OLAP or OLTP is there. What is data warehousing and what is online analytical processing? Okay, these topics are related to data warehousing. So what is data warehouse? Okay, we can define in many different ways, but not rigorously. A decision support database that is maintained separately from the organization's operational database. Okay, it is separately maintained at different place. Support information processing. Okay, data warehouse supports the information processing also by providing a solid platform of consolidation historical data for analysis. So finally, what we can say, a data warehouse is a subject oriented and integrated and time variant and non-volatile. Non-volatile means permanent storage basis. Volatile means, okay, at present moment data is available. Okay, if the power is not there, if the system is not available, the data will not be available. When can we say non-volatile? Non-volatile means, okay, the data is permanently stored, right? And non-volatile collection of data in support of management's decision-making process. So finally, we can say the process of constructing and using data warehouses. Data warehouse subject oriented. So which is organized around major subjects such as customer, okay, data warehouses related to customer, the data warehouses related to products or sales, all those things. Okay, customer database, product database, sales database, focusing on the modeling and analysis for data for decision makers, not on daily operations or transaction processing, which provides a simple and concise view around particular subject issues by excluding data that are not useful in decision support process. And finally, data warehouses, okay, which is integrated, constructed by integrating multiple heterogeneous data sources with the different data sources may be from relational databases, flat files, online transaction records, all those things. Okay, from the different resources, we'll create a data warehouses. It can be from relational databases, flat files, online transaction records. Again, the same thing. Once we integrate all this, then we need to perform the data cleaning and data integration process as usual. Data cleaning and integration techniques are applied, which ensures in naming conventions. Okay, naming conventions are different. For example, in relational databases, one naming convention was there. In flat files, another naming convention is there. In online transaction record, another naming convention is there. Okay, confusion may occur. Okay, ambiguity may occur. Okay, due to this one. Okay, all these things must be, these ambiguities must be solved. Naming convention, encoding structures, attribute measures, etc. among different data sources. For example, when we talk about hotel price, okay, we can talk in the form of currency, tax, breakfast covered, all those issues. When the data is moved to the warehouse, it is converted. It must be converted, and it is time variant also. So what do you mean by time variant? The time horizon for the data warehouse is significantly longer than that of the operational systems. What do you mean by operational database? Current value data, data warehouse data, which provides information from a historical perspective. When we talk about historical perspective, means when we talk about the banking system, we can have the records, we can have the data warehouse, which contains 1 year transactions, banking, bank customers transaction, 2 year transactions, past for 2 years transactions, 5 years transactions, 10 year 10 year transactions also. Every key structure in the data warehouses contains an element of time explicitly or implicitly. The time is very important. When each and every transaction is recorded, what is the time on date, time and date is very, very important. And data warehouses must be non-volatile. A physical separate store of data transformed from the operation environment, and operational update of data does not occur in the data warehouse environment. Okay. Okay, and these are the terminologies related to data warehouse. Remember, when it comes to data warehouses, these two techniques are procedures are very important. Online OLTP and OLAP, online transaction processing, online analytical processing. Who are the users of OLTP and OLAP? Just see the difference. We can understand by seeing the difference. OLTP, when it comes to OLTP, the users are clerk and IT professional. When it comes to analytical processing, okay, the user is the knowledge worker. What is the function of OLTP? Day-to-day operations. This is for decision support. Database design. What type of database is needed? Application oriented. When it comes to OLTP, it is application oriented, or analytical processing, it is subject oriented. So data, when we talk about the data, that is current data, up to date, detailed, flat, relational, isolated. When it comes to analytical processing, it is historical, 1 year data, 2 years data, 5 years data, 10 years data, and it is summarized data, multidimensional, integrated, consolidated, right? And usage of OLTP is repetitive, whereas OLAP, it is ad hoc basis. Access, what type of access we can have with OLTP? That is, we can read or write, index or hash on primary key, and lots of scans are there. When it comes to OLAP, lot of scans are needed every time whenever we perform the analysis process. Unit of work, that is short, simple transaction, complex query. Okay. And when you see the database size of OLTP, it is 100 MB to gigabytes. And when it comes to analytical processing, online analytical processing, 100 GB to terabytes of data, right? Okay, just see the difference. These two are very important when it comes to data warehouses, online transaction processing and online analytical processing, right? So why a separate data warehouses? That is high performance for both the systems, DBMS. Okay, when we talk about database management system, which is tuned for OLTP, accessing methods, indexing, concurrency control, and recovery techniques are there when it comes to the relational database management system. And when we talk about warehouse, it is tuned for OLAP. DBMS is tuned for OLTP, warehouse is tuned for OLAP. That is complex OLAP queries, multidimensional views, and different data. So different functions and different data. As usual, missing data, what to do with missing data? Data consolidation, consolidating data. In that, what we can perform aggregation, we can perform the aggregation, summarization of the data from heterogeneous sources. Okay, just see the diagram. A data warehouse, when we talk about data warehouse, a multi-tiered architecture. Here, the other sources, operational databases. From this, we can extract, we can perform the extraction, transformation, loading, and refresh. Here, metadata is there, monitor and integration. Metadata is nothing but, we all know that one. That is data about data, more detailed information about the existing data, right? Just simple definition. Metadata is nothing but data about data, more detailed information about the existing data. So data warehouse is connected to all these things, data marts, okay, and monitoring operation, integration operation is there, and afterwards we have the OLAP servers and server. Finally, we can perform the analysis query. We can have queries, reports, and data mining. 3 data warehouse models. Okay, when we talk about models, how many types of data warehouses we can have? One is enterprise data warehouse. Second one is data mart. The third one is a virtual data warehouse. Enterprise is that what collects all of the information about the subject spanning the entire organization. When it comes to data mart, a subset of corporate-wide data that is of value to a specific group of users. And when it comes to virtual warehouse, a set of use or optional databases, virtual, physically not available. Okay, we can get or we can extract from different sources from different places logically. And these are the functionalities. Extraction. What do you mean by extraction? Data warehouse functionalities. What we can do with data warehouses, that is extraction, transformation, and loading. We use the word ETL. ETL is related to data warehouses, that is E for extraction, T for transformation, and L for loading. Data extraction, get data from multiple heterogeneous and external sources. And data cleaning, as usual, we must clean the data before performing any operation, detect errors in the data and rectify them when possible. Transformation, okay, we need to convert from one form to another form so that we can easily understand, so that we can perform the analysis process. Convert data from legacy or host format to warehouse format. Loading, that is sort, summarize, consolidate, compute views, check integrity, build indices, indexing, indices and partitions. Whenever we need partition, okay, we'll create a partition, separate partitions, so that we can easily understand, easily you can move from one place to another place, easily you can integrate. Refresh. Refresh means update. If new data is added, that must be refreshed together. Metadata. So what do you mean by metadata? Metadata is the data refining warehouse objects. Description of the structure of the data warehouses. In this we have schema. Whenever we talk about databases or data warehouses or data mining, schema is very important. In what way the data is stored, how the data is represented, how the data is connected. Okay, this is the idea of schema. Schema is very, very important. The starting point of the data warehouses or databases or whatever it may be, right? So what type of data is available, how the data is stored, how the attributes are, how many attributes are there, how those attributes are connected, what type of meaning is there, what type of connection is there between attributes. All this comes under schema. Schema, views, dimension, hierarchies, derived data definitions, data mart locations. And next we will see about the from tables to spreadsheets to data cubes. The basic thing is that table. In general, we have the information is available in tables or the spreadsheets. Generally, we used to say that Excel, Microsoft Excel is the best example for spreadsheets to data cubes at the higher level, right? A data warehouse is based on a multi-dimensional data model which views data in the form of data cube. A data cube, such as, for example, when we talk about sales, which allows data to be modeled and used in multiple dimensions. Okay, dimension table can be, for example, when we talk about item, it can have item name and the brand, the item brand and item type. And when we talk about the time, okay, it can have the day, week, month, quarter, and year, right? And fact table contains measures such as how many dollars sold and keys to each of these related dimension tables. Okay, this is just see the example cube. When we talk in data warehouses, the basic one is that cube. The data is stored in cube or cuboid. We used to say that a lattice of cuboid. Okay, this is the first one at the highest level. We have the 0 dimension. It is called apex cuboid, and this is the level 1. Okay, next one 0 and first level 1, that is 1D cuboid, and the next one we have this 2D cuboid. Next we have 3D cuboid, and fourth one is the 4D. 3D means three attributes will be there. 3D, when it comes to 3D keyword, time, item, location, and the three are connected, right? When we talk about this one, time, item, supplier. When we talk about this point, this 3D cuboid, that is item. Okay, that means information about item, location, and supplier, right? And at the beginning, zero to dimension is there, which is treated as all. Then one dimension, only one attribute is there: time, item, location, and supplier. And when it comes to this point, combination of the previous layer, previous points, right? Time and item, time and supplier, time and only two attributes is there. At the 3D cubed, three attributes are there. At the 4D cubed, four attributes will be there. And how these are connected together? Connection is that okay, logical meaning must be there. With this lattice of cubites, we can extract the information about the attributes and their values. And conceptual modeling of data warehouses. We have the star schema, modeling data warehouse that is related to dimensions and measures, star schema, snowflake schema, and fact constellation. Generally, constellation what is related to stars. Okay, because millions and millions of stars will be there, and how those stars are nearer to each other at a particular group, constellation, galaxy. Generally, we say that galaxy schema when we talk about galaxy, right? Star schema, a fact table in the middle connected to a set of dimension table. Snowflake, a refinement of star schema, where some dimension hierarchy is normalized into a set of smaller dimension tables, forming a shape similar to snowflakes, snow, and fact constellation. Example of star schema. Just see this one. This table, main table, sales fact table. We call it as fact table. And next, this is about time. This is about branch. This is about measure, location, and item. Attributes and their values, right? The table and add values. And how these are connected to, and what type of relationship is there between factor table and the remaining tables. Okay, this is snowflake schema. Snowflake means, okay, here this is also connected to another one, subs, okay. And location, the city is connected to location, okay, sub part of this location, city is sub part of location, supplier is sub part of item, right? Okay, this is the idea of snowflake schema, how the data is distributed. Okay, this is about the factor constellations. Constellations just like the stars are galaxy, right? One is connected to another one, and the type of relationship between one table to another table. This is about dimensions, graphical representation, data cube measures, algebraic. Okay, this is not related to us. Multi-dimensional data. Okay, just see the diagram 3D. Sales volume, when we talk about multi-dimensional data, and for example, when we talk about the sales in an organization, sales volume as a function. Okay, when we talk about the sales volume, which is a function of product and month and region. Three dimension. One dimension is region, another dimension is product, another dimension is month, right? For example, dimensions: product, location, time, hierarchical summary paths, that is industry, category, product, region, country, again country and city and office. When we talk about year, quarter, month, week, and day in detail. Okay, these are the dimension names. One dimension name is region, another dimension name is product, another dimension name is month. Okay, just sample data cube. Just see the sample data cube. Okay, product. Product can be, for example, one dimension is product. Under this product, we can have TV, PC, personal computer, VCR, and some is there. Some of all these things. And when we another dimension, its name is date. When we talk about date, it is first quarter, second quarter, third quarter, and fourth quarter. Quarter means here 3 months, every 3 months. In a year, we have 12 months are there. 12 months are divided into 4 parts. Each part contains three months. 3 months is called as quarter. First quarter. In business, we use the word quarter, quarterly, half yearly. Results are sales, are transactions, whatever it may be. How much sales has been done in a particular first quarter, second quarter, third quarter, and fourth quarter, and the sum. And when we talk about the third dimension, that is the country in a USA, for example, USA, Canada, Mexico, and the sum of all these things. Okay. This is the best example, a sample data cube. When we talk about sample data cube, one dimension is product, and the second dimension is date, the third dimension is country. And every dimension has some value, sum of all those values. And cuboid, just now I said cuboid, all product, the first 1D cuboid, that is product, date, country, and 2D means combination of two. For example, when we talk about this one, this point is related to product and date is there. And this point, this is connected from product and country, product comma country. And this point, this is date and country. And 3D cuboid, 3 points must be connected. 1, and this is 2, and this is 3. Product and the date and the country. Okay, very important one. Typical online analytical processing operations. Okay, what type of operations are there? Yes, please look into this. Typical online analytical processing operations. What type of operations performed under this online OLAP? First one is that roll up or drill up. Okay, that means that is nothing but summarize the data, summary. By climbing up hierarchy or by dimension reduction, climbing up hierarchy, upward direction. Okay, lowest level to the highest level, tree structure. And drill down or roll down. Okay, that is reverse of roll up. Okay, from higher level summary to the low level details, finding or extracting low level details. Okay, this is roll up is by climbing up hierarchy. Okay, they are moving towards the top level. Here, top level to the lowest level. The detailed data are introducing the new dimension. Slice and dice. Okay, slice and dice means project and select slice. Slice means okay. The best example is that bread is there. Bread is cut into slices. Slice 1, slice 2, slice 3. One particular area small. Okay. Pivot, that is rotate, reorient the cube, visualization 3D, and drill across. The other operations are drill across and drill through. Okay, these are the operations. Roll up, drill down, slice and dice, pivot, drill across, drill through. And this is star net quality model, just like a star. Okay, how the attributes are connected, interconnected, and we can easily understand. For example, shipping method is there. So many are there. Shipping method, customer orders, customer, product, division, and region. And again, in this, inside this, country, city, or when it comes to time, annually, quarterly, daily. When it comes to customer order, with contracts and orders. When it comes to product, it is product line, product item, product group. When it comes to division, that is district level, salesperson, and product item, right? And when it comes to shipping method, we have different methods are there, air, express, or truck. Right? How these are connected and how their values are connected together logically. Here, each circle is called a footprint. Remember that one, each circle is called as a footprint. Browsing data cuboid. Here we use the concept of visualization, OLAP capabilities. Yes, just 10 minutes will complete. We'll stop this one. Regarding data warehouses. Design of data warehouses, a business analysis framework. Okay, when it comes to business, we must create a data warehouses. How the data warehouse must be created. Here are the 4 views regarding the design of data warehouses. Remember that one. Okay, for any particular business, we must create a data warehouse framework. That is top-down view, data source view, data warehouse view, and business query view. While creating a data warehouses, okay, we must remember this. That is top-down view, data source view, data warehouse view, and business query view. In detail, top-down, that is top-down and bottom-up. And when it comes to software engineering, it is a waterfall spiral model. Typical data warehouse design process. Okay. Choose a business process to model, that is regarding orders or invoices. Choose the grain. Grain is nothing but smaller level, atomic level of data. What is the basic unit of data we use in that particular model? Choose the dimensions also. Okay, the dimensions must be, we need to think about the dimensions. Okay, just see the one example. Data warehouses development, a recommended approach. Okay, when we think of data warehouses, when we want to create a data warehouse, this is the idea. Data marts are there. Data mart, enterprise data warehouses are there, and again combined with distributed data marts. Again, this is at the highest level. We have multi-tier data warehouses. Data warehouses uses the applications of data warehouses. One is information processing, analytical processing, and data mining. Data mining also related to data warehouses, right? Just remember 3 kinds of data warehouses applications where this data warehouse concepts are applicable. That is information processing. In this we have supports query. We can execute the query, basic statistical analysis, reporting, generating reports, cross tabs, tables, generating tables, charts, and graphs. And when it comes to analytical processing, just now we have seen OLAP operations, that is slice and dice, drilling, pivoting, all these things. And data mining is there. We know that some data mining functionalities are there. From online analytical processing to online mining. Next, data efficient data cube computation. Indexing also very important. Okay, so that we can efficiently access the data within fraction of seconds. When we talk about databases or data warehouses, indexing is very important, right? Efficient processing, OLAP queries. Okay, same as when we have the query language for databases, relational database management system. We use the SQL, structured query language. For data warehouses also, we have OLAP queries are there. Same. OLAP architecture, that is relational. In this, different combinations are there. When it comes to OLAP, that is relational OLAP, ROLAP, and multi-dimensional OLAP, that is MOLAP, hybrid OLAP, that is OLAP, and specialized SQL servers. Attribute oriented is not needed. Class characterization, initial relation, prime generalized relation, table, and how these are connected. Basic principles of attribute oriented induction. Presentation of generalized results, that is generalized relations. Cross tabulation is nothing but by using tables. That we have visualization techniques, that is pie charts, bar charts, curves, cubes, and other visual forms. Quantitative characteristics. Mining class comparison. Yeah, this is summary. Whatever we have discussed till now, that is data warehousing and data warehousing architecture, design and usage, implementation, data generalization, and these are the references, right? Okay, for today's class, we'll stop here. Tomorrow, we'll see the next topic. Okay, in brief, right? In today's class, we have discussed about data pre-processing techniques and data warehouse. What is data warehouses? The functionalities of data warehouses, all those things, right? Thank you. For tomorrow, we'll have a session at 11 o'clock, Saturday, 11 a.m., right?
Yes, sir.
Can I stop? Yeah. Any queries or questions or any suggestions are there for tomorrow's class?
No, sir.
Yeah. Okay. If you want slides, I will provide the slides later. Okay. All these are from the standard textbook. For data mining, we have the Camber book is there, very important, very standard one. High standard book is there. If you want these slides, you can. I'll provide the slides also, right? You can revise it, all the slides. Yes. Thank you. Shall I wind up? Yeah. Tomorrow we'll meet at 11 a.m. with next chapter. Thank you.
Thank you, sir.
Yeah.